Hello everyone, my name is Mr. Cho, and I specialize in mathematics here at Elite. And today, I brought a couple AP calculus questions that I want to go over with you guys. So here we go. So question number 1, it says a water tank contains 30 liters at time t equals 5 hours. And it says water is being pumped into the tank at a rate R of t, where R of t is measured in liters per hour. And t is then of course measured in hours. It says selected values of R of t are given in the table above. Using a right Riemann sum with 3 subintervals and data from the table, what is the approximation of liters of water that are in the tank at time t equals 16 hours. Okay, so right now this is a Riemann sum problem, right? And a lot of the students struggle with the Riemann sum problem thinking that it's something really complicated. But one thing you guys have to know is that on the AP exam, it's actually, the numbers are not going to be that too complicated, right? So what is that question actually asking us? So right now we have a water tank and water is being pumped into the tank. That means the volume inside the tank is going to be increasing, right? And the rate at which how fast the water is being pumped in is given by the table values above. So in order to know how much water is in the tank at t equals 16 hours, we have to first find, or at least try to find the approximation of integral 5 to 16 of R of t. Remember, this is the, so we have to find the integral from 5 to 16 of R of t dt. And this will find us how much water has pumped into the tank from t equals 5 to t equals 16 hours. Right? And we'll be using the right Riemann sum to make the approximation. So whenever I do Riemann sum problems, I always like to draw a graph with the table values above and draw the rectangles myself, right? Let's plot the points at t equals 5, and we have t equals 8, and 12, and 16. And the table values kind of go from 12, 10, 8, and 5. So I feel like we only need 5, 10, and 15 should be enough. So at t equals 5, we have 12. At t equals 8, we have 10. At t equals 12, we have 8. And at 16, 5. So we can kind of already see as time goes on, the rate at which the water is being pumped in is getting decreasing, right? Now, what does it mean that we have to use right Riemann sum? That means the upper right corner of the rectangles will be touching the data points. So when I draw my first rectangle here, I have to make sure the upper right corner is touching the data points. That's the first one, here's the second one, and here's the third one. And Riemann sum, really all we have to do is add the area of the 3 rectangles, right? And we should already know how to add the rectangles. So the first rectangle, base is 3 times height 10. There we go. Now the second rectangle has a base of 4 and a height of 8. And the third rectangle will have a base of 4 again and height 5. We just have to add them up and we will get 30 plus 32 plus 20, which should equal 82. So is our answer 82? A? Well, College Board, they like to trick us sometimes with the answer choices, so we have to be careful. The integral here, 5 to 16, only finds us how much water was pumped into the tank from 5 to 16 hours. So we kind of have to add how much there was initially at t equals 5, which was actually given to us in the problem in the beginning. It said 30 liters in the tank already at t equals 5. So on top of the 82 that was pumped into the tank for the 11 hours here, we have to do 30 plus 82 to get the total amount, 112 liters of water at t equals 16. So the answer is C. And here we have number 2. It says f prime is x minus 3 to the 4th power times x squared minus 8 all over 16. and they gave us g of x is f of x squared minus 5. And they're asking us, what is g prime of 3? Okay, so they don't actually give us what f of x is. Instead, they give us f prime and asking us to find g prime, right? So first thing we gotta do here is to take the derivative of g and find g prime of x. When we take the derivative of the g here, take the f prime of x squared minus 5. But that's not it. Don't forget, anytime we're taking a derivative of a function within a function, we have to multiply by the derivative of the inside by the chain rule. We have to multiply 2x. Now, since they're asking us to find g prime of 3, let's plug in x equals 3. So we will have f prime of 3 squared minus 5 times 2 times 3, which will give us f prime of 9 minus 5, which will be 4. And we will have to multiply this by 6. Now let's find what f prime of 4 is going to be. Well, good thing is they actually gave us f prime. So all we have to do is just plug in 4 into the given f prime. So we have 4 minus 3 to the 4th power times 4 squared minus 8 and divide it all by 16. That will give us, well, 4 minus 3 is just 1. 1 to the 4th power is just 1. So we have 16 minus 8 divided by 16. 8 over 16, which will give us 1/2. Now we just plug in this 1/2 into the f prime of 4, giving us 1/2 times 6. So our answer will be 3. So answer D. So one thing here that we have to be careful is when we take the derivative of g prime, when we take the derivative, we have to make sure we multiply by the chain rule, the derivative of the inside function here, 2x, by the chain rule. Chain rule is probably one of the most important derivative rules that we have to know for the AP exam. You will be using this a lot, so make sure you don't forget about the chain rule. And that's it. Good job, guys. Thank you.